Okay, this is the last video for Unit 3, and it's about, as it says, about relativistic momentum and Newton's equation. And probably everyone's always wanted to know, when will we ever use the famous E equals mc squared? And the answer is today. But we'll do the momentum first. Relativistic momentum is not really very difficult to understand, just the calculations are a bit yuck. It's just the gamma that we've used before, so it means that relativistic momentum is gamma mv, and at most speeds, normal speeds, we know that gamma approaches 1 or is as good as 1, and therefore there's no change to the momentum. So it only matters at those extreme speeds. So, as the speed approaches the speed of light, the mass of an object increases, and so does the momentum. Now, this is one of the reasons why it's always been assumed that it is impossible to actually reach the speed of light, because as you get very, very, very close to the speed of light, then theoretically the momentum and mass become infinite, and therefore you can never ever produce enough energy to get right to that point. Now, if you ever have to rearrange this and do it the other way around, V equals P over M square root of 1 plus P squared over M squared C squared. I'm hoping you never have to use that. Nothing that complicated was on last year's exam. Okay, Einstein's famous equation. Einstein, I think, is most well known for his energy. Now, I think you're going to cop at some stage the E total equals gamma mc squared, but that really isn't the one that's being used in exams. All we're using in exams that I've seen so far is just the famous E equals mc squared, and this is when energy is created from mass. So, e.g. in nuclear explosions. Or fusion like at stars. So the mass is converted directly to energy. So obviously you get enormous amounts when you multiply it by 3 by 10 to the 8 squared. We'll follow this one up obviously in class with a number of calculations. We know a little bit more about what's likely to be expected now, having seen a couple of exams, and we're hoping the questions just stay relatively straightforward. Okay, that should be the conclusion of Unit 3.